Okay, we're almost to the end of chapter 5, and so what we're going to look at now is how to graph linear inequalities. We graphed inequalities on a number line, and with a number line, that's really what we call a one variable inequality because we had just our x's, or we had just y's in our inequality. But now we're going to have inequalities that have x's and y's. So we're going to be graphing them on the xy graphs, and so we need to kind of reiterate what happens with these inequality symbols and what they mean. So we have the inequality symbol less than or equal to, so here's my less than, and here's my or equal to. Now the or equal to line meant before that we had a filled in dot. And so how that's going to represent now is our line is going to be a solid line. Just like any graph that we normally graph would be a solid line. And what's going to happen is because it's less than, we're going to shade below the line. Now our next type of inequality symbol is just the less than symbol. And the less than symbol was an open dot on the number line. So how that's going to represent now is we're going to have a dotted, or also known as dashed line. And so that's going to kind of look like this. And because it's less than, that means that we're also going to shade below the line. Now on our next one, we have the greater than or equal to. Now the line underneath means that, again, we would usually have a filled in dot, but that means our line is going to be solid. Because every point on that line will actually be a solution to our inequality. And then because it's greater than, we're going to shade above the line. And then our last one is just the greater than symbol. So this is going to be a dotted or dashed line. And then because it's greater than, we're going to shade above the line. So we're going to run through a couple examples because I think it just makes more sense when you run through them. So we have our first equation. Graph the solution for y is less than negative 2/3 x plus 7. So we're going to start with 7 on the y-axis. And then here is our slope, so we're going to go down to right 3. So down to right 3, down to right 3, down to right 3, up to left 3. And so now we have our dots. So now what we have to do is we have to figure out what type of line. So we have the less than symbol, which means we're going to have a dotted or dashed line. So when I draw the line, I'm going to make it dotted. And then I'm going to have solutions to this inequality. So all sorts of points that actually work in that inequality if I were to plug in the xy coordinates. And so because this is a less than, that means all values lower than that line should work. And so that means I'm going to go ahead and shade in everything below the line. So if this is my line, I'm going to shade everything below that. So I'm going to look here and I'm going to shade everything below that, which means every point in this shaded region will work in that inequality. So tons of answers. Everywhere that's shaded, every single coordinate there is an answer, is a correct answer to the inequality. And so that's why we graph it. So we could talk about all those possible correct answers. Okay, so now we're going to graph another one. We're going to start at -6 on the y-axis. So I'm going to go down to -6. And then my slope is 3/4. So I'm going to go up 3, right 4. So up 1, 2, 3, right 1, 2, 3, 4. Up 1, 2, 3, right 1, 2, 3, 4. Or go backwards down 1, 2, 1, 2, 3, right 1, 2, 3, 4. And then I have to figure out what type of line is it. So my symbol is greater than, which means it's going to be dotted. So I'm going to go ahead and draw a dotted line. And then because it's greater than, I'm going to shade above the line. So I'm going to go ahead and take my little highlighter, and anything that's above the line, so I usually start at the line and I draw straight up, so then I know where to shade in. So everything from here up is all shaded. And that is our solution. So every point in that shaded region is an answer. And if you were to plug in those XY coordinates, it would actually work. Okay, next one. Graph the solution for y is greater than or equal to 3x minus 5. So I start graphing at -5. So I go to the y-axis at -5. And then my slope is 3. So that is up 3, right 1, because it's 3 over 1. So from here I go up 1, 2, 3 over 1, 1, 2, 3 over 1, 2, 3 over 1, 1, 2, 3, 1, 2, 3, or down 1, 2, 3, left 1. Now I have to figure out what's going on with my line. So if this is a greater than or equal to, the or equal to means that it's going to be a solid line. So I go ahead and I draw a solid line connecting those points, which means these points are solutions. So all of these points would work in the inequality. And then because it's greater than, I'm going to shade above the line. So now I'm going to go ahead and take my handy dandy highlighter, and I'm going to shade everything above. So I start at my line, I go straight up, which means everything on this side of the line gets shaded. And so again, everything in the shaded area is a solution, which is why we graph our answer. Okay, next one. We're going to start graphing at +4 on the y-axis. And then my slope is -1 over 1, which means down 1, right 1. So from here I go down 1, right 1. Or up 1, left 1. And then I have to figure out what type of line it is. So now I'm going to go back to my inequality symbol, less than or equal to. The or equal to means it's a solid line. So I'm going to draw a solid line connecting those points. And then the less than means I shade below the line. So I'm going to grab my handy dandy highlighter. I'm going to start at my line, and I'm going to go straight down, so that way I know the side I need to shade. So everything on this side of the line is my less than. Now every point in my shaded area should be a solution to the inequality. So if I pick a point and plug in the XY coordinates of it, it should make the inequality true. Okay, so now we have special cases. Now it's not written in the y equals mx plus b form. So we've practiced solving for y. We're going to practice some more solving for y. So I'm going to go ahead and move my x to the other side. Oops. So I'm going to minus 2x from both sides. So now I'm going to have -3y is greater than or equal to -2x plus 6. And now I'm going to divide everything by -3. Now in chapter 2 we talked about something special that happens. And that is if you divide by a negative, we need to flip the symbol. And so right here, We're dividing by negative, so this symbol has to flip. So the 3's cancel, negatives cancel, I have y. Symbol flips to less than or equal to. Then over here our negatives cancel, so I have 2/3 x. 6 divided by -3 is -2. And now I can graph. So when I graph, I'm going to start at -2 on the y. Then we're going to go up 2, right 3. So up 2, right 3, up 2, right 3, up 2, right 3. Or down 2, left 3, down 2, left 3, down 2, left 3. And then I go back and I look at my line or my inequality symbol and I determine how do I graph my line. So when I look here, I have an or equal to, so it's solid. So I draw a solid line. And then I have a less than. And so less than means I shade below the line. So I'm going to grab my handy dandy highlighter. I'm going to take my line, draw right below, so that way I know where it's shaded. And so you have to be really careful with these ones because when you divide by negative, you have to flip the sign, which changes where you shade. Some people try to use the original inequality symbol to determine that, and you can't. You have to use the one from when you have solved for y, because you may have that flip occurring. Okay, so in our next one, I'm going to move my x to the other side. So I'm going to minus 1x on both sides. So now I have -2y is less than -1x minus 4. I divide everything by -2. Since I'm dividing by negative, this symbol has to flip around. The 2's cancel, the negatives cancel, and I get y is greater than negatives cancel 1/2 x, negatives cancel plus 2. So when I graph, I'm going to start at that 2 on the y-axis, and then I'm going to go up 1, right 2. Now I go back to my inequality symbol, and it is greater than, not or equal to, so it is a dotted line, or dashed. Some people like to say it's dashed. And then because it's greater than, I shade above the line. So now I've got my highlighter, it's shade above the line. So above, so I'm shading all of this area. And that is our graph. So we're almost done with chapter 5. So now that we've graphed inequalities on a graph, now we're going to graph a system of inequalities. So 2 of these on the same graph and talking about where is your true solution.